Okay. So what did we see so far? Okay, this is the code that we were working yesterday, right? And let's run it. So this is hotel data set, right? And it has 33 columns. Okay, yesterday we worked to find, we looked at a number of missing values, correct? And hmm, and we looked at number of values missing in a row, in a column, right? So for column, more than 80% data we deleted. For row, more than I think 12. Okay, data we deleted. Okay, this was original data, right? And yes. So this was the final stat. Okay, so after doing removal of rows and columns, we are left with these many six columns. Now, if you remember, okay, children, babies are your numeric data. Okay, and agent. Okay, so let's. I think we have it here, right? We looked at number of values that were. Let's see this. Okay, these are created for missing indicators. Let me hide this print. Okay, instead, open this print. So here, these are your numeric columns, and these are non-numeric columns, right? And we need to check the numeric and non-numeric columns, right? And other print, okay, we can comment out, right? We don't need it. Okay, let it be. So let's look at the data type of these. So children, okay, so you see here, adult, children, babies, okay, agent is also numeric. Okay, so children is numeric, babies numeric, agent is also numeric. Then here, if you see meal, country, deposit type, meal, country, and deposit type. Okay, all three are non-numeric, correct? So non-numeric. So we will take here as the mode. Okay, we'll take mode here for handling this. Okay, so now I'll show you that you don't even have to check. Okay, if here, like, I'll show you first how you can directly convert, and second time is we can go using loop. Okay, you can go through loop and check if it is missing, and then we can replace with missing sum, right? So let's say I say here for column in, okay, DF numeric, right? So these are the columns which have already filtered numeric there. Okay, so DF numeric dot columns, okay, dot values. Now see, we have removed few uh, columns, right? So when we try to access these columns, we may not, we will get errors for sure. So instead, let's redo it. Okay, let's rework on it. Okay, so let's get refreshed. Okay, so that the columns which have been removed will not be part of this. Okay. Okay, for column in, okay, numeric column values, and we will check. Okay, if it is missing, we can copy here. We have we know here how to copy missing value, right? This is for mean, okay, percentage. Doesn't matter, even mean or sum, anything you can take. So, yeah, I'm just copying this, but anything, sum is also okay, mean is also okay. I just need to know if that column has missing value or not. Okay, if it is here, that's when we need to perform our operation. Okay, so we will say median equal to df of coal, okay, dot median, okay, and df of coal equal to df of coal dot fill NA. That means all the NA values not available, right? Blank will be treated as NAs here, right? So all NAs only I want to replace with median. Others will be as it is. Okay. So now if you check, okay, count for missing values. Hopefully these three numeric columns, okay, will not be empty. Okay. So I'm going to say here, I'll put it in print so that we can see the output. So your children, babies, and agents should not be there in the list now, the last list. Yeah, see? So those three have been handled. Similarly, we can handle non, this thing also. So for handling, okay, so we'll say handling numeric missing values, right? Now we can do same stuff for non-numeric. So for non-numeric, we'll put here non-numeric, right? Non-numeric, select exclude. So we'll exclude everything, number here. And then we will use this variable here, okay? Mean missing value percentage. Now here, we don't have to find median. We need to find the mode, right? We'll say mode. So mode is your df coal dot describe. When we describe, we get the values, and now I will say describe top. Okay, top means it will give us the highest value. Okay, and then here we will replace with mode. Now when you run it, hopefully all the missing values would be handled. See, count for missing values, there are no values here. Okay, so this is how you can drop missing values. Now there is an option here to remove the duplicate values. Okay, we'll see if there are any duplicate values or not. Drop duplicate values. Why are we not dropping duplicate values before? Because now we have more chance of remove duplicate, right? Most of the blank values are being replaced by median or mode, okay, repetition. So we might see, okay, some values duplicate. So before, I'll say shape before dropping duplicates. So you can say here your df data frame dot shape, right? So this will tell us number of rows, number of columns. Okay. Now I'm going to say df equal to df dot drop. Okay. Drop what? Okay. ID will anyway be different, right? So ID we can keep it. And I'll say axis equal to 1. And drop duplicates. That's it. Now you can check if any rows has been removed or not. Shape after dropping duplicate. Okay, so we are dropping ID column here. Okay, and then checking because ID will be unique, right? So ID, okay. So see here, ID has been dropped, and from 1,19,000, we got only 87 now. So those many values were duplicate. We have to drop ID because ID was unique. So if we include ID, then we won't get in duplicate. So saying, okay, let's remove ID. Apart from that, are there any duplicate values? So we got so many duplicate values. Okay. So with that, we will finish off this particular exercise. Okay. So with that, we complete our data visualization part, data visualization using Python part. And this is the book which is with you, data visualization using Python, right? Okay. And I'm showing you each chapter of the book. Sorry?
No, nothing.
Yeah. So if you don't have it, you come and take it.
Sure.
So this is the first chapter which talks about the importance of data visualization, why data visualization, some examples here, what information it gives. Okay. There's one example here which talks about, let's say this is a telephone bill. Okay. Okay. So, so let's say a telecom company like Airtel. Airtel has this bills of people, right? Let's say 200 people. Now, these are long distance telephone bill calls. What information can you get from this? Right now, if you have individual bills of this is just 200, maybe you might have 1,000, 10,000 such values. Now, okay, that 1,000 values is of no use to you, isn't it? Because it's individual values, you can't even read them, forget about analyzing them. So what do we do? In such case, we create histogram. Okay, so you arrange the values from minimum to maximum. Okay, and I told you, right, you create a bin between 8 to 12, right? 10, around 10. So it could be 8 or 12 kind of bin. So if you see here, minimum bill is 0. It says dollars. So let's assume dollar itself. So minimum bill is $0 and maximum is some here 103, 118, 118, 109, 119. Okay, so let's assume that 119 is highest. That means your value ranges from 0 to 119, almost 120, right? Now, if you take a range of $10, 0 to 10, 10 to 20, you get perfect 12 bins. So you then create a histogram, okay? And 0 to 10, how many bills are there? 10 to $20, how many bills are there? So if you create that, you will get a, okay, so this is the table, this is called as frequency table, okay? 0 to 15, okay, here we have taken 0 to 15. So you take 0 to 15 and frequency means how many values are appearing between 0 to 15. Okay, so you'll see 17, 71, 15 to 30, 37. And this range has to be same. If you take 10, all has to be 10. If it is 15, all have to be 15. Okay. So you create this, then you create a histogram, right? So this tells you, from here you can make some sense, right? By looking at 200 numbers or 2,000 numbers or 2 lakh numbers, you can't make any sense. So when you create a histogram, you can see, okay, maximum bills are between like $0 to $30. Okay, most people are here. And then the most of the other next highest people is from $90 to $120. Very few people are between $30 to $75. Now you get, so now here you can actually visualize the entire data into, right? It becomes so easy to now understand your own data than going through each data. Okay, so that's the purpose of histogram. Now, when you look at this data, what does this tell you? Okay, now what business knowledge can you give to your team? So obviously, it means that you have maximum people here, and second
Yes.
maximum range is on the right side. Okay, medium is on medium people is least.
Middle.
Right now, depending upon your business, okay, you would be taking an action. Now, if it is retail, okay, so you're looking at the bill value, okay, of each customer, and you're plotting this. So you should be saying, oh, most of my customers buys less than $30. Is there a way I can push them to at least middle part so that they spend more, right? So you say, okay, buy one, get one free or something like that, so that, okay, more people spend more money with you, right? So okay, so that's the purpose of retail company. But if you're a telecom provider, Airtel or Vodafone or Jio, you'll be concerned about these people who are spending more than $100. Okay, so I mean, these are people who are spending more. Now they're at risk. Tomorrow, if new company comes up and they announce that long distance bill is cheap, these people will leave you first, isn't it? Because their bill is high. Okay, so when Jio started free calls or fixed 300 rupees or 200 rupees calls for a month, what people whose bill was more than 300, 400, they were the first one to move, isn't it? Because drastic reduction in their bill. People who are spending 100 rupees per month, for them it was not a problem. But who were spending more than 300, they would easily switch to Jio, right? Same thing. So that's why when you log in, when you try to recharge bill, right, you'll have 200 options, because they know they have to cater to all kinds of people who are in the city for one day, people who wants to make just one call, people who wants to use internet only for 1 hour, to annual plans, right? Because they need to cater to all kinds of customer, right? You cannot say, no, I will not have this plan. If you don't have this plan, that means you're leaving out a segment of people, right? So, for a telecom provider, this is risky. Okay, tomorrow, if competitor launches a plan where international calls becomes cheap, okay, these are the people who will dump and go. So imagine 20% people leaving you overnight, right? So you need to come up with some plan, or you need to tell them that why don't you switch to this plan, your bill will become lesser. Okay, I remember like 10 years back, okay, I was using this Airtel. Uh, so they used to send monthly bills, and the month bill, they will say, you are in correct uh, plan, or they'll say, if you move to this plan, you would have saved so much. Okay, so they make those recommendations because they don't want people to spend more. If you spend more, your competitor, if they come with some better plan, you will switch. So okay, so the point I'm trying to make is your analysis of the data depends upon your domain. Telecom people would want to move this high paying customer to middle. Retail customer would want this low paying customer to move to middle, right? Same data, but approach will be totally different. So here you see almost like 30% customers are here. Okay, and this is like almost like 50%. 108 is more than 50%. So your interpretation will vary, okay, depending upon your domain. Now, here, if you look at the second example, okay, this is a box plot of quick service restaurant. Okay, so you have companies like Popeyes, Wendy's, and McDonald's and Hardee's. Their service time is mentioned here in box plot. So let's assume this 95 is second. Okay, so minimum time that Popeyes take to prepare is almost like 100 seconds, right? And maximum is about 245 seconds. Median is about 1 maybe, 160 around. Okay. Now, if you move to Wendy's, minimum time is less than Popeyes, right? Even maximum time is less than Popeyes. Median is, so if you are hungry, whom will you choose between Popeyes and Wendy's? Probably Wendy's, right? Because you expect to get your food faster compared to Popeyes. Even maximum, if you take, it is, just about median. This is median line. So just about median of your Popeyes, right? So see here, Hardee's the least value is almost same as most of the other thing, but see the highest. The variation is so high. Highest goes almost like more than 295, right? Higher so far. And if you take Jack in the Box, they take more time to prepare. The lowest is also like more than the median of most of the values, right? So Jack in the Box takes on average more time. Maybe, they may be fresh. They're making everything in front of you. Could be the reason. Okay. What would be the reason? We are not talking about the reason here. We're looking at the time. Okay. And Hardee's is like, you can get it in within 2 minutes, or it can take you 30 minutes, right? So the variation is too high. Maybe they have a large variation of menu items. Okay. Okay. So this tells you their minimum, maximum, and median service time, right? Quarter one, quarter three. This is quartile one, this is quartile three, right? Quartile one, quartile three, data of their service time. So probably if you are feeling hungry, you should go into the Wendy's, right? That's what it says. If you're in a relaxing mood, you can go to Jack in the Box. Sit, relax, and food will come later. It takes almost like 45 minutes also. That's why I can compare the service time of each restaurant. Okay. So this was chapter 1 that is in the book. Now, chapter 2 is about develop your research question. See, before you start doing any work, not only data visualization, not only machine learning, okay, anything. First, you need to understand what's your question. What is that you're supposed to do, right? Are you supposed to, increase the service time? You're supposed to decrease the response time? Are you supposed to focus on increase the profitability or revenue, right? In the telecom example, which I was talking about, if your focus was to increase the revenue, then you will say you guys move to middle, right? But if your focus was to improve the profitability, then probably you might take a different approach, right? You're making loss. You want to make some profit. You don't mind customers losing you, but you want to get into profit. So your approach, your data that you need will vary depending upon your business problem, isn't it? So that's why I said business problem, okay, is important for doing any work. So understand the business problem. Understand what your research question is. What do you want to do? And what we say is research questions or your business problem will be either your financial goal, okay, or internal business process. Financial goal example here is increase gross margin, increase revenue, right? Your internal business process could be that the process that you're using is taking more number of steps. You need to reduce the steps. You need to shorten the total process time. You need to shorten the number of steps that is taken to uh, perform certain action. So what is your goal? It could be learning. You focus on employees. Okay, innovation and learning is more focusing on employee. How do we train the employee? How do we make employee become better? And fourth initiatives the companies going to take is about customers, right? How to improve customer satisfaction, how to retain more customers. Your retention rate is low. You want to increase that, right? So any objective, the business starts will be one of these four parts only, either related to financial or one factor can impact more than one, right? If you retain customer, it will of course impact your customer target, and also it will increase your revenue, isn't it? So one initiative can be part of one or more of these, right? So these are the four main areas. So what is that as a business they are trying to do? And based on that, you will choose your data, right? So there's some examples here, okay? How to allocate your marketing budget. You have been given marketing budget, how do you allocate? So you want to see, okay, what the companies are doing in this scenarios. So you'll see here, most of companies are spending on direct marketing activities. Okay, then second highest is social media. Okay, third is your marketing employees itself. Right, so this will give some idea. Right now you have 100 rupees to spend. This will give you some idea about how to spend, where to spend. Right, but ultimately decision is yours. This is just to begin with, right? And then you will see the feedback, right? And then you will decide what to do. So okay, so this is an example of marketing management. Okay, so business challenges for a marketing manager. Okay, and you read through this, it'll tell you, what challenges they have, what they start, okay, and what problems they face while working on this, right? So ultimately, it is your business objective that will decide what you want to do. There are some areas, some questions so there's some questions related to retail analytics. Okay, where the data analytics, the data visualization will help them. So these are the examples. There are case studies where it has actually already helped the company. So this is example of Lowe's and Marks and Spencer. Okay, so to manage their assortment optimization and shelf space allocation. Assortment optimization is, let's say you bought a shirt, you decided which color to buy, fine. But then you have to decide assortment also, right? How many large t-shirt you need, how many small. That's also a big decision for a retailer, right? How many t-shirt is one question, and then how much size, each size, whether small, large, medium, XL, double, they won't get all equal, right? They'll depend upon the number of customers that they come to the store. They'll decide what size of t-shirt and how many, okay, how many of them they should order. So that's an example where you can read through it. Okay, so they actually saved millions of dollars by using analytics. This is customer driven marketing. Okay, so example of Tesco is here. Okay, then you have fraud detection and prevention. Okay, so these are some of the areas of retail analytics, marketing manager. Okay, then you have integrated forecasting, localization and clustering. Okay, so these are some examples of retail analytics, and similarly, there will be a lot of examples from different industry where you use your analytics. Now, see here, this is an example here from financial services. This is about anticipated net job creation and reduction. So, fintech in next 2 years, fintech in next 5 years, fintech in next 10 years. So, this is tech jobs, and this is normal finance job. So if you see after 5 years, normal finance job is decreasing and your fintech jobs are increasing. Of course, fintech jobs, the percentage increase is much more than the percentage decrease. But your net to net employee, if you see from traditional traditional financials, they have to move to tech roles, right? So this is net job creation percentage over next 5 or 10 years. So this tells you that if you have to hire people, in which segment you'll have to hire. You can't hire more general purpose, right? Because in future, you're not going to need them. Or you need to start training your own internal employees who are maybe expert CAs to understand what machine learning is, right? Or what fintech is. So this is how your data will be consumed by your business. Okay, our focus is to make such data, okay, based on whatever source we have. But should also keep in mind what business, how this can help the business. Okay, so there are some examples here. This is an example of tweets that were done in the US in 2014. Okay, so total tweets. Okay, so if you see, these are some of the days where there were maximum number of tweets. Okay, so these are areas. So you can see entire tweet, okay, volume from Jan to December, and then you can actually see the the highs, okay, where there were maximum tweets done on the day. Okay, so these are some examples. Okay, this is another example of this is okay, so let's talk about GDP. Okay, assume that this is GDP. Okay, so now GDP will tell you which country. So when you look at this data itself, the highest GDP is for US, second highest is China. Probably Russia and India are similar, right? So you will be able to get the data by looking at the bubble size. So this is called bubble graph, what you see. So different graphs will give you different data, right? Then this is one example that I have, performance analytics, how to perform, how to analyze performance. And they are called your dashboards. Okay, so dashboards will have more than one. So I think this is by a company, tech company based in Europe. Okay, something like, Philips or Siemens or some company like that. And this is their dashboard. Okay, they can track. That's why currency is in Europe. So you can track their performance, right? So this is called dashboard. When you put multiple graphs together and the people from that industry, from the company, they can continuously track. Okay. So real-time update happening from the backend. So you will be creating these graphs as well. Right. So that's an example here. That's what I have in chapter 2. Chapter 3, you talk about how to get the data. So it talks about data types, okay, mean, median, mode, okay, and then the sources of data. Kaggle is the most popular data source, but apart from that, you can even get data from Google. Google has dataset search.research.google.com. You can get the data. Microsoft has its own website. Amazon has its own website, registry.opendata.aws. UCI. Most of the examples you'll see on the internet about machine learning examples, they will be using UCI, okay, University of California data. Then government will have their own website. Every government, India government, US government, they all have their own data set. You can go there. Apart from that, you have Kaggle, where you can get the data, and there are other websites as well. World Bank, GitHub. Okay, you'll find a lot of data these days. Okay, you can even get the data by web scraping. So towards the end, last chapter, there is an example where you can use, okay, web scraping to get the data. But web scraping is sometimes illegal. Some websites will not allow. Okay, I think here only I have the example. Okay, here only you have the example of reading a Wikipedia page. Okay, so you read a Wikipedia page, okay, and so this talks about list of Indian billionaires. So there's a Wikipedia page. You can, read the Wikipedia page, get the content. So this is like reading the HTML page and getting the content. Now you have to clean that HTML. So these are steps of cleaning the HTML page. And then once you clean them, so this is the screenshot from the Wikipedia. Okay, so okay, you'll be able to read this. This table has this data. So once you have the complete HTML code with you, you can get the access to this table and get the data from this table, and you can create a data frame, that is pandas data frame on your table. Okay, then it talks about importance of mean, median, mode. Okay, how to calculate mean, median, mode here. This is an example of correlation here. Okay, then you have symmetric histogram, skewness, positively skewed, negatively skewed. Then we get into measure of variability. You have variance, standard deviation, right? Range, IQR. An example of doing using Python to do same stuff. Then we spoke about the kurtosis, right? So thinner the graph, which is your leptokurtic, will have less deviation, right? Then we discussed about accuracy and precision. Okay, this is type of correlation here, positive, negative, strong, weak. This is an example of correlation using Excel. Chapter 4 talks about cleaning the data. So here, first you have to understand NumPy, Pandas, right? We have done this, right? NumPy, Panda examples. So there's some examples of NumPy. So this is what is there here. We call data wrangling using NumPy and Pandas. So SciPy is also there. NumPy, SciPy, Pandas examples are here. So after this is like foundation for doing analysis. After that, we get into data analysis. Okay, so this is like dropping. Okay, the set theory. Okay, I think hotel booking. This is the example that we did yesterday. Okay, so it is in chapter number 4. Okay, so So you can actually see the code is here. There are a lot more examples here than we did. Okay. So you can, if you practice here, you'll see more visualization here in the book. Okay. So yeah, this is what we did yesterday and today. Then you go to chapter number 5. How do you prepare the data? Data cleaning. So this is very similar to what we did for machine learning, right? We did scaling, missing value, scaling, okay, handling the categorical value, outliers you can check, outliers can be removed. So this is your data wrangling step, okay. Now chart type, okay. So 6, 7, 8, 9. So here this is like the chart type, the different types of charts, okay. So if you talk about comparison, if you are trying to compare two data, or you want to see the similarity and differences between two data, right? So you can use graphs like bar chart, box and whisker plot, bubble chart, bullet graph, okay. Then if you want to show the proportion, percentage, okay, so and then bubble chart, okay, relationship, heat map, we did heat map, right, yesterday. Distribution. So these are different types of plots and when to use what, just for your idea, okay. So there are so many graphs. Now, then you have some basic plot like we did yesterday, histogram, we did box plot. So there are some, examples of simple graphs here. Okay, we did some of these, right? We did scatter plot, we did histogram, bar graph. There's some examples of simple graphs. Then there's some advanced examples you can practice here. This is example of word cloud. Okay. So this is chapter 6 that you have, and chapter 7, okay, talks about different tools that are available in Python. Okay, we used Seaborn example and Matplotlib, but apart from that, there are a lot more other tools that you have. So first we'll talk about non-Python tools. Okay, so here you have Tableau. Okay, we have done Tableau and we'll do Tableau next week. We'll do one example of Tableau. Then Quilk, you have Adaptive Insights, Plotly, Raw Graphs, Google Charts, Fusion Charts. These are tools, non-Python tools, right? Then if you go to Python itself, Matplotlib. Okay, so you have Matplotlib, Seaborn. Apart from that, you have a lot more. Okay, you have ggplot, Bokeh. We haven't done these things. Okay, you can practice one example. See the same thing. Okay, plot doesn't change. What changes is the UI, the appearance of the plot. Okay, so you have ggplot, Bokeh. These are the libraries in Python. Okay, Plotly. Then you have Pygal, Altair. Okay, Geoplotly to draw maps. You can draw a map of any country. Okay, we have example here is for India, and missing number. Okay, these are different plots, and there are some links also which you can visit. These are like very advanced tools. Okay, okay, if for your knowledge you can go visit and see them. Okay. Then on chapter 8, presentation. Okay, presentation is important. So this is what I want. Okay, this has plotting. Okay, so I'll put this in the link. You should practice chapter 8. Chapter 8 is for practice. Other chapters we have done or just for theory aspect. Chapter 8 has a lot of visualization. It has taken data set and done. I think the unigram diagram that we have done also is here. Yes. Okay, so this unigram diagram is also from here. Yeah, we have done this. Okay, not all the plots, but see, this is the unigram. Okay, this is what we did 2 days back. Okay, so this chapter 8 is for to practice, and chapter 9 is the one simple project that we have, and it combines your web scraping plus your plotting. So chapter 8 and 9, okay, is for you to practice. It's like a mini project. Okay.
Yes.
So if you practice this is like revision. Okay, all the concepts are done here. So you're reading the data from website and then we are plotting, okay, different like male versus female performance and things like that. Okay, so with that, we complete our data visualization here. Okay, I'll put this link in that blog page and you can practice. All right.
Yes, yes.